Real quick here. Okay, for unit 9.6.
Hey, stop the talking, guys.
Unit 9.6, okay? We're going to be working on find vertices, and something called asymptotes. You spell it ASYMPTOTES. Find vertices and asymptotes for a hyperbola. Yeah, that wasn't your cell phone or anything. Find vertices and asymptotes for a hyperbola. So, yes, obviously we are learning a new shape today. So, the standard form for a hyperbola is very, very similar to that of an ellipse. It's x minus h squared divided by a squared minus y minus k squared divided by b squared equals 1. The only difference between an ellipse and a hyperbola is the minus in between. That's it. Okay? That is it. If there's a minus in between the two things that are squared, it has to be a hyperbola. That is the only kind of shape. Now, you can also see this in a different format. It can be backwards. It can be y minus k squared over a squared minus x minus h squared over b squared equals 1. Now, the reason there are two is because hyperbolas actually can be in two kind of different formats, okay? You're still going to have a grid just like normal, but if the x is first, okay, so if the x squared part is positive, then we call this something called, I call it an x hugger, okay? It hugs the x-axis, meaning that it will look like this. Hyperbolas are essentially like two parabolas back to back. Okay, so these wrap around the x-axis if x is first, if x is positive. Now, if y is first, that would mean that the y term is positive, the x term is negative. So this is what I would call a y hugger. Okay, it wraps around or hugs the y-axis. Okay, that is, sorry. Thank you.
Wait, what class do you have?
Hey.
Hey, you're in class?
So,
Yeah.
Wait.
this one wraps around the y-axis. So, let's get started. So, if I'm going to ask you to find the center,
She's so little, but she makes her
find the center, vertices, and sketch. We will get to these asymptote things later. Okay, so first we're just going to start with find the center, the vertices, and sketch. So for example number 1, if I give you the equation x squared over 4 minus y squared over 9 equals 1. X squared over 4 minus y squared over 9 equals 1. So, first off, what would be my center of this hyperbola? Center is at 0, 0. Almost always you're going to have a 0, 0 center. Okay, so we're just trying to make it a little bit easier on you. So almost always we're going to have a 0, 0 center. So we're going to draw our grid. Center will be at 0, 0. Now, just like an ellipse, how far out do you think I move on the x-axis? 2. Okay, just like an ellipse, we take the square root of the x denominator, and you're going to move out that far on the x-axis, so meaning side to side. So move out 2, left and right. How far out do you think you move up and down? 3. 3 up, 3 down. Now, for an ellipse, you would connect these. We are still going to connect these, but kind of with a different shape. I want you to make a rectangle that goes through all of these points. And I want you to do it in dotted lines because I don't actually want it to be very dark. Okay, so in some dotted lines, I want you to make a rectangle that goes through all of those points. Now, this rectangle is going to give you the guidelines for what are called the asymptotes. Okay, the asymptotes are lines that go through the corners and the middle. So the first one goes through the corner and the middle. I do want you to put them beyond the rectangle. Okay, so making them a little bit longer than just the rectangle. Then we're going to put another one on the other direction that goes through the corner and the middle. So we're going to make kind of like a big X. Now, the way that you can tell where your hyperbola is open is what was first. So since the X part is positive, are these going to go around or hug the X-axis or up and down and hug the Y-axis? The X. So these are going to go here. It starts here. The reason we have these asymptotes, these are the guidelines for how wide your hyperbolas should be. These are the guidelines for how wide these should be. So these are pretty wide. Then the last thing here is the vertices. Okay, if I had just a parabola, where's the vertex of just a regular parabola? Like right in the middle, right? This time we're going to have two of them, and they are right in the middle of here. So notice this has nothing to do with which points are farther apart. Technically, these points are not farther apart. So whichever one is positive, that's where your vertices are going to be. So I want you to label these. So what is this vertex? Label that point right there. 2, 0. And what is this point right here?
-2.
-2, 0. That is your answer. No. What has to be positive? No, that's a negative point. No, this is -2, 0. Okay, let's try another one. Same thing. I would like you to find the center, vertices, and sketch of y squared over 16, minus x squared equals 1. Y squared over 16 minus x squared equals 1. So first thing we notice here that doesn't look quite right is that there's no denominator. If there's no denominator, what can I really make your denominator? 1. Makes it a little bit easier. Okay, what is the center for this hyperbola? 0, 0. Okay, so if we're going to make our sketch, so at 0, 0, how far side to side will I move?
4.
Not 4. Side to side is the denominator of the x. So how far do I move? 1 over 1. So sometimes, since this one starts with y, you have to pay attention, okay? The x part tells you how far to move side to side, so it might not be the first thing. So you do have to pay pretty good attention on these. Now, how far do I move up and down? 4. So please, please, please be paying attention on these. So which one's first and which one's second. So make your rectangle.
Rectangles are hard to draw.
Do the best that you can. Okay, draw the asymptotes through them. Remember, asymptotes are lines. Now, for this one, is this going to be going around the y-axis, so up and down, or the x-axis? Are these going to be side to sides or up and downs? Up and down, because the y part is first. So these ones are a little bit skinnier than the last ones. And then finally, the vertices are at the center of each hyperbola. So what are your vertices? This one is what? 0, 4. And this one is what? 0, -4. So 0, 4, and 0, -4. Any questions so far? There are 8 examples. Pretty sure I said that a while ago. Number 3, 16y squared minus x minus 3 quantity squared equals 64. 16y squared minus x minus 3 squared equals 64.
Do you have the answers to these?
No.
Do you have the answers to any of them?
I don't know when I'm correcting it. Don't worry about it. So, what does my hyperbola have to equal? What does it have to equal? 1. So how do I make this equal to 1?
Divided by 64.
Divide everything through by 64. Divide everything through by 64. 16 over 64 is going to reduce really nicely, so y squared over 4 minus x minus 3 squared over 64 equals 1. From there, what is my center? What is the center of this hyperbola? Not 0, 3. 3, 0. This one's backwards, so you have to look at the x part first. So 3, 0. These are ones that you just have to pay really good attention on when you're doing these. So over 3 up 0 is your center. From the center, how far will I move side to side? 8. Okay, look at the x denominator. Okay, square root of the x denominator. So you're going to move 8 to the right. Put a dot. 8 to the left. Put a dot. How far up and down? 2 up, 2 down. Now, make sure you're not moving from 0, 0. You're moving from the center. So those are not on an axis. Then write in your, or draw in, excuse me, your rectangle. Do the best you can with your rectangle. Draw in the asymptotes. So through the middle and the edge of your rectangle. Through the middle, out the edge of your rectangle. Now, are these hyperbolas going to open up and down or side to side? Up and down because they are y first, so y is positive. So these are like ultra wide. These are very wide. And finally, where are my vertices? Up and down or side to side? Where will the vertices be? Up and down or side to side?
Side to side.
Up and down. It doesn't make any sense to have them side to side. That's not even on your drawing. So up and down. So label the vertex. What point is this? 3, 2. And what point is the bottom one? 3, -2. So that is how we do vertices and, how we find the center, vertices, and sketch of hyperbolas. Questions so far? Okay, next thing that I will ask you to do is rewrite something in standard form. So write in standard form. So standard form essentially means equal to 1 and things with denominators in the bottom. So write in standard form for number 4. Rewrite in standard form 16x squared minus 4y squared minus 96x minus 16y plus 64 equals 0. 16x squared minus 4y squared minus 96x minus 16y plus 64 equals 0. So this is just like what we did with ellipses and circles and parabolas. What do I have to do to get this in standard form? Put the x's together, put the y's together, and move the number. So we're going to group your x's. So 16x squared minus 96x, leave some space, minus 4y squared minus 16y equals negative 64. So move that 64 to the opposite side. Then what am I going to take out here? 16. You have to take out whatever coefficient, whatever number is attached to the square. So these will be different numbers. So for the x's, we're going to take out a 16. Left behind is x squared minus 6x. What would I take out for the y's?
4.
Negative 4. Okay, has to be a minus in between because remember these are hyperbolas. So negative 4, left behind is what? Y squared plus 4y. If you do negative divided by negative, you get a positive. Equals negative 64. Now complete the square. Okay, so completing the square says we take the middle number divided by 2 and square it. So it's going to be negative 3 squared. So what am I adding in the parentheses with the x? Plus 9. What do I add to the opposite side? 16 times 9, so plus 144. How about for the y's? Take your middle number again, divide by 2 and square it. So what do I add in the parentheses with the y's? Plus 4. What do I add to the other side? Minus 16. Okay, negative 4 times positive 4 gives you negative 16. Rewrite this. So we have 16 times, what's my binomial squared? X minus 3 squared. How about the y's? Y plus 2. Remember, that comes straight from that parentheses. Equals, if you do negative 64 plus 144 minus 16, you should get positive 64. What's my next step? Divide by 64, exactly. Now again, these are worked out already intentionally to be nice numbers, okay? You're not going to be left with any number in the numerator. So x minus 3 squared over 4 minus y plus 2 squared over 16 equals 1. Now, make sure that you have this second one in parentheses. If you don't, that would technically mean that you should have distributed the square, which is too much of a process, and distributed the negative. So make sure that you keep things in parentheses here. Anyone have questions on how I did that? Now, technically, I could ask you to graph that. You could be asked for the center and the vertices. I'm not asking for that. But it is theoretically possible. Okay, let's try another one. Same thing. I want you to rewrite in standard form for number 5. 2y squared minus 5x squared plus 12y plus 10x minus 37 equals 0. 2y squared minus 5x squared plus 12y plus 10x minus 37 equals 0. What do you think I'm going to have to start with? Get all the x's together, get all the y's together. What is going to come first in this equation, the x's or the y's? The y's. Why would the y's come first? Well, because it's first and because it's positive. Okay, if you started with your x's, you're going to have a negative out front, and that's going to be messed up. Okay, remember, we want the positive part first. Positive part, then the negative part. So here, we're actually going to group up the y's first. So 2y squared plus 12y, leave your space, minus 5x squared plus 10x, and then yes, move the 37 to the opposite side. What number can I take out from the y's? 2. Left behind is y squared plus 6y. Leave your space. What am I going to take out from the x's? Negative 5. Left behind is what? X squared minus 2x. Okay, pay attention to those. Positive divided by negative leaves you a negative. Complete the square. So take your middle number divided by 2 and square it. So what do I add in the parentheses with the y's? Plus 9. What will I add in the parentheses with the x? Write it.
I was asleep.
Write it. Okay, here. Take your middle number divided by 2 and square it. So negative 1 squared means we're going to add 1. What do I add to the other side? Sorry, I should have added 18 here. This one, you add a negative 5. So if you work that out, we're going to get 2 times y plus 3 squared minus 5 times x minus 1 squared equals what? 37 plus 18 minus 5. 50. Now, that's not a perfect square, but that's okay, because what am I going to do with it? Divide it away. So divide all the parts by 50. Divide every part by 50. We end up with y plus 3 squared over 25 minus x minus 1 squared over 10 equals 1. I will not, by the way, ask you to graph this because this is not a nice perfect square in the denominator. Okay, I will not be asking you to graph this.
She's like trying to put her most weight.
Trying so hard.
Any questions so far?
Can I go to the nurse now?
No.
It's a bit, like, why are you here? My teacher, like, jumped on my foot.
Next thing you're going to do is write the equation. Almost done. Write the equation. 3 more. Write the equation of the asymptotes. ASY, MPT, OTES. Write the equation of the asymptotes of the following hyperbolae. Hyperbolas, sorry, plural. Hyperbolas.
Is this just like an extra classroom?
Number 6.
This used to be
X squared over 144 minus y squared over 25 equals 1. This is the coffee room.
Happy to.
That doesn't have
after our class.
X squared over 144 minus y squared over 25 equals 1. Before you can find the equations of the asymptotes, we basically have to graph this. So what would be the center? Center is at 0, 0. Okay, we're just going to make a rough sketch. Doesn't have to be perfect. So 0, 0. How far will I move side to side? 12. Don't have to put all the dots. I will encourage you to write the number though. Okay, write how far you're going side to side. How far should I move up and down? 5.
Yes.
5 and 5. Make your dotted box, dotted rectangle. Okay, the asymptotes are going to go through the edges. Now, will these be side to side or up and down? Side to side because they wrap around the x-axis. So if I asked you to, we could identify the vertices as well. Okay, I'll just give them to you. This vertex would be at 12, 0. This vertex would be at negative 12, 0. But what I really want to know here is the equation of the lines, of the asymptotes. So I want the equation of this line. What does the equation of a line look like? What form is an equation of a line? Y equals mx plus b, right? So if I need to rewrite this in y equals mx plus b form, what parts do I need? The y and the x always stay exactly the same. I need the b. What's the b? The y-intercept. What's the y-intercept here? Where does it cross the y-axis? 0. These are set up on purpose, so you're never really going to have to deal with anything that's not at 0, 0. Okay, it used to be that we'd put them like way out in the sky and you had to find, it was a lot more difficult. It's always going to be at 0, 0. So really I just need the slope. The slope, would you agree if I go from 0, 0 to this point, it'd go the same, right? It goes through that point. So really to get from here to there, how much do you go up? How far do you go up? 5, which is why I labeled this. How far do you move over? 12. That's your answer. Y equals 5 over 12x. And to make it even easier for you, to find the equation of the other one, how far do you go up to get from here to here? Up 5. How far do you go over? Negative 12, right? So all you really have to do is put a plus or minus in front of that. And you have both equations of your asymptotes. So all you're really doing is finding the slope. That's it. Okay, it's always going to start from 0, 0. So you're going to figure out how far do you go up, how far do you go over. So this is our actual answer. Try another one for number 7. Okay, number 7. Find the equation of the asymptotes of y over 9 quantity squared minus x over 7 squared equals 1. Y over 9 squared plus x over 7 squared equals 1. Is this a form that we like to graph from? No. What do I have to do? What do I want to do first? Square the bottoms. Right. So really this is y squared over 81 minus x squared over what? 49 equals 1. Do you have to do that? No. But if you don't, a lot of times people will see this and they'll say that you move on the y-axis 3 spaces, which is wrong. Okay, it should be 9 spaces. You have to take the square root. So what is the center?
0, 0.
Center is at 0, 0. It's not always going to be 0, 0, but especially when we're asking for the equations of asymptotes, it's always going to be a 0, 0 center. It just makes life a little bit easier. How far do we move side to side?
7.
Yes. Okay, it's the second one. So side to side, you're moving 7. I'm happy that you actually paid attention to that. How far do we move up and down? 9. Draw your lines, or excuse me, draw your rectangle. Connect the edges with some lines, the asymptotes. Would these hyperbolas be opening side to side or up and down? Up and down. Do you have to draw them? Not necessarily. But let's just be complete and do them. Because I could ask you lots of other questions. Then to find the equation of the asymptotes, we're always going to have a y equals. Basically, it's just the slope because it starts at 0, 0. So how would you get from this middle point to this point? Up 9 over 7. If you want to write the equation of both, we just write y equals, put a plus or minus in front. Still going to be 9 over 7, and just the x, you can drop the 0. That is your answer. Okay, last one, I promise. For number 8, I just want you to state the slope. State the slope of the asymptotes ASY, MPT, OTES. State the slope of the asymptotes of the following. State the slope. X squared over 100 minus y squared equals 1. X squared over 100 minus y squared equals 1. Let's fill in the blanks here a little bit. If I don't like that there's a non-denominator here, what can I write? Over 1. Do you have to? No, but you can. Okay, what's the center? Center is what? 0, 0. You can leave it, but if it makes you think that it looks funny, you can just write it over 1.
Why do you have to graph it if you can figure out the y and actually not graph it?
Because most people are visual learners, so they need to see both. Okay? If you can figure out that really slope is what? But what is slope?
Rise over run.
Okay, I get that, but as far as letters.
Y over x.
Slope is actually y over x. Okay? I'm not going to show you that way though, because it's easier for people to just see the picture and to count, generally. Not always, but generally. Okay, how far out do you move, side to side? 10 and 10. Label it so it makes life easier. How far up and down? 1 and 1. Make the box. Draw on your lines. And finally, find the slope. So how far do you have to draw the vertices? No. Do you have to draw the hyperbolas? No. But if you want to be complete, of course you could. And I could ask you all of those lovely questions. So, what is the slope of this line? Up 1 over 10. Now, I'm just asking for the slope here. So the slopes of the asymptotes would be plus or minus 1 over 10. Okay, I'm not asking for the entire equation. So just make sure if it asks you for the equation, you write a y equals mx plus b equation. If it's just asking for the slope, it's just the m part. Homework is worksheet 6. You're doing numbers 1 through 26 all. Worksheet 6, number 1 through 26 all. Anyone have questions?